Greetings, teachers. My name is Riya Narayan and my teammate is Asta Gupta. We are here to present you a part of the CIE2 component of Basics of Python, which is explaining a variety of functions under NumPy and pandas. So I'm going to start with NumPy. Basically, what is NumPy? NumPy is basically a Python library which can, perform various functions on array. So let's start with the very basic step, that is importing the library into the notebook. So here, as you can see in the very first code, we have used the word import and we are importing NumPy. After importing the NumPy, we are going to declare an array. The array name is A. It can whatever you want it to be. And we're going to write NumPy dot array and we're going to give the elements of the array. It can be anything from numbers, that is integer data type, or float data type, or string data type. And here I have given the integer data type and I have printed the array. I'm going to copy this function and I'm going to go ahead onto the new notebook. I'm going to paste it and I'm going to run it to see if it prints it or not. And here it goes. It printed the array A. Now, let's see the next step. So as you can see, NumPy is a very big word and ahead in every function you have to import it. So not import it, actually it's not necessary to import it every time, but you have to use it at the time of declaring an array. So not to not use such a big word, we can just give it a short form that can be anything you want also. Here I have imported NumPy as NP so that further in any code, if I use NP, it will automatically understand that I'm referring to NumPy. So I'm gonna copy this code. I'm gonna paste it here. In this code, we are declaring an array M using the word NP. So now the code automatically sends a signal that NP means NumPy, and we're declaring a two-dimensional array. So I'm gonna run it, and here it goes. It prints an array. So telling you the basic features of an two-dimensional array, it is that this whole row will be index number 0, and this whole row will be index number 1, 0 and 1. It has 3 columns. Column 1, 4 will be 0, 3, 5 will be 1, and 5, 6 will be 2. Moving on. So what functions can we perform on an array? Let's start with the most basic thing we can do. The most basic thing we can do is that here we have done is we have declared an array A and array A2. Here we have so many elements. And what if we want to perform functions from an element of one array with an element of another array? So here, for example, in this line of the code, we are adding two elements of two different arrays. So we have taken the index number 2, the element at index number 2 of array A. So index number 2 will be, this will be 0, this will be 1, and this will be 2, that is 5. And the index number 7 of array 2, 0, 1, 2, 3, 4, 5, 6, 7, and 8. That means 18. So that's how we are going to do. So here, it is adding A of 2 and A2 of 7. It will be 16. And I'm going to go ahead and run this code here. And it gives us 21. That's how you can perform similar functions, that is addition, subtraction, multiplication, division. And I'm going to copy this whole code. I'm going to paste it here. And I'm going to run it. And it gives us all the answers. It subtracts the element at index number 5 of array A from the element at index number 8. It multiplies the elements and it adds and divides the elements by 3. That's how the most of the basic functions are performed. Now, what if we want to find what if we want to find what number is exactly present at a specific spot? So that's how we use this code. So what will do here is that first I'm gonna print AB so that it's clear. AB is printed. Now I'm gonna print this. So in this array, what if you want to know what's the element, what's the number, what's the name, what's the string at index number one will be, this is 0 as I said, and this will be 1. So 1 and 2, 0, 1, and 2. We will go it according in the column wise. And here 0, 1, 2, and it will print 8. So let's see if it does. It printed 8. That's how other examples will run too. We run it here. Let's try and run it and see. It gives us, so 0 will be this row and 0, 3, 0, 1, 2, 3, which gives us 0, 1, 2, 3, and which gives us 4 and 1, 1, 1, and 0 and 1, 7, 0, 1, 0 and 1 will be 2. So that's how we can find out, uh, you know, what element is present at a specific spot. Now, what if we want to know the dimensions of an array? So that's where the dot shape function enters. I'm going to copy this and I'm going to run this. Now here, it gave us the dimensions of the array, which is 2, 4, that is 2 rows and 4 columns. We also declared an array M. We can do the same with M. I'm going to find out the shape of M. I'm going to run it and it gives us 2, 3. Here you can see 2 rows and 3 columns. So that's how it goes. Now moving on to the next function is dot reshape. What if we want to give a different shape to the array, but with the same elements? So that's how we can do this thing. So if we reshape it, it's going to give us this. So yeah, that's how we can use it. Now, what if there are two arrays, for example, A and B, and we want to merge it into a whole completely new array? So the concatenate function helps us to do that. Here, I'm going to run this code and I'm going to show. This is array A1 with 3 elements. This is A2 with 3 elements. And we will form a whole new A3 array with the same elements. So I'm going to run this code and here it goes. It gave us 1, 2, 3, 4, 5, 6, which are the elements of A1 and A2. Now, what if we want to give it, we want to create a dimensional array? What if we want to stack it? So that's where the stack function enters. That is dot stack. So using the same arrays, I'm going to create a whole different array, which is A4, and it's going to give us the array which will be 1, 2, 3, and 4, 5, 6. That means it will have 2 rows and 3 columns. Let's see. So 2 rows, 0 and 1, and 3 columns. Now the next step is, the next function we have is to find where. So where is a function that helps us find the uh, index number of the element. So here we found out we had the index numbers and we found out the element. Here we have the element and we have to find the index number. So that's the use of the where function. In this new array, ARR1, we have these elements. And by using this function, so x is a variable which will store the index number at which that particular element is present. So np dot where brackets ARR1 is equals to 4. So it's gonna find out at which index number or numbers is 4 present at. So I'm gonna run this code, and here it shows us. It shows us 3, 6. So 0, 1, 2, 3 we have 4, 4, 5, 6 we have 4. It also shows us the data type, that is integer, and its size in bits, which is 64. So that's how you can use the where function. If I want to use this and find the position of, for example, 2. So I'm going to run it, and will be 1 and 4. 0, 1, that is 2. 2, 3, 4, which is also 2. Now, moving on to the next function, which is dot sort. So sort is very self-explanatory word. It's going to sort the array. So I'm going to start with an example of a string. So here are 3 names, and this function will rearrange the array and print it. It will rearrange it in ascending form, and here it goes. So it rearranged the array according to the first letters L, P, and R. If we want to try it in, if the elements are of integer and if it's a dimensional array, we can try it according to that also. So what's going to happen in this code is that it will arrange the elements in a row, not according to the columns, but according to the row. For example, in this thing, it is 12, 24, 6, 47. So the number 6 will be at the first index, the first place, that is 0. Then it will be 12, 24, and 47. The same goes for here. It will be 9, 18, 60, and 73. So let's run it. It will be 12, 24. Right now we have just printed the array. Now, if you want to sort it, we are going to use the sort function. That is this code. Here, we'll sort it np.sort ab1. And here it goes. As said, 6, 12, 24, 47, and 9, 18, 60, and 73. That's how we use the sort function. Now, what if we want to, we want to generate a random number, out of nowhere, so that we can do from the function random. So it's going to use an integer. So in the bracket, you can give a limit, the number, the maximum number it can go up to. So here we have, for example, given 50. So it will produce a number that is 50 or below 50. We have 43. I'm going to run this code again. We have 13. Running this code again, we have 6. Now, what if I change this to 100? If I change this to 100, 29, and 39, okay, 5, 82. Here we go. So it's a number, above 50 because we changed the limit to 100. Now, the next very interesting function in the NumPy is to plot a graph. So basically, we can declare array through np.array, and we can import mat.lib.pyplot as PLT. Of course, we are not gonna use it every time. Such a big name, it's time consuming. So if we run this function and code. So basically, it's gonna plot these two arrays and it's gonna mark them with this little dot. So if we run it, it's gonna take some time. Yeah. So here we have this. So what it did was it plotted the point 1 and 6. So 1 here and 6 here. 2 comma 4. 2 is this, 4 is this. 3 comma 8. 3 here it goes and 8. 4 comma 2, 4 and 2. 5 comma 10, 5 and 10. So that's how we can plot a graph. Now, what if we want a more clear understanding? What if we want the visuals to be different? So that's also something that we can do. We can give the color in which we want the plot graph to appear. So we have, so this is the code plt.plot bracket x comma y comma marker is equals to this dot comma color is equals to red and marker face color is equals to black. So when this code runs, these lines will be red and these dots there, which is these dots which you see here, are gonna be black. So let's run this code. Here you go. Red lines and black dots. So that will let the programmer, you know, make the graph very understandable. Now the last function which I'm going to explain is dot random dot choice. So what it does is that here we can give a specific size of an array, and we can give a set of numbers from which the code, the code will run, the code will execute, and will choose 10 random elements from the set of elements that we have given. And it can repeat the elements also. It can be 2, 3, 4, 4, 5, 6, and 1, 1, 2, 3, 4. It can be anything, and its size should be 10. So let's run this code. Let's see what it gives. So it gave us 2, 4, 3, 2. 2 is repeated 2 times. 5, 6, 1, 1, 3, 6. 6 is repeated 2 times. 3 is repeated 2 times. And 1 is repeated 2 times. So, and it is of size 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, I'm gonna give some different numbers. There we go. And I'm gonna make the size to 5, I think. No, not 5. I'm gonna make the size to 9. I'm gonna run it and it gave me a array of random order of my selected elements and size. So to give a recap of what all I explained, basically how to import the library, how to define an array, how to declare an array, how to print an array, how to give a short name to the numpy so that it's less time consuming, how to perform various functions such as addition, subtraction, multiplication, division on an array, on two different arrays, how to sort the array, or how to find the element at a specific index, how to find the shape of the array, that is dimensions, and how to reshape those dimensions. Important thing is this, that you have to, while using the reshape function, you have to give a valid set of numbers, so that a set which a dimension which is possible with that kind of array. So yeah, then we moved on to concatenate function which merges to array. Then we moved on to stack function which merges the array but in with different rows and columns. Then we saw the dot where function, in which we found out to how to find the index number of a specific element. Then we found out how to sort an array of string elements and of an integer elements, which can be two-dimensional. Then we found out how to just generate a random number of, and we have the authority to decide the maximum limit of that number. And Then we saw this very important function, which is how to plot a graph. And here we imported matplotlib also, and we saw how to make it more understandable for the one reading it. And then the very last function we saw was how to generate an array of our choice of elements and of our choice of size, but in a random order. Now my teammate Asta will continue with the library of pandas.